Right, so we touched around the acceptance testing and TDD, and that's what we're going to go into. So I wanted to ask, how many of you are programmers in the room? Hands up. All right. What are programmers? What are the rest? Are you managers? Project managers? Good. So, sorry? Business analysts, awesome. I have a little bit for everybody, so I hope this is going to be good. So, TDD started 10 years ago. Well, more than 10 years ago, because it started in 2000, we're now in 2012, by Ken Beck. It fathered XP, which is Extreme Programming, and later on TDD, and he came with a book in 2000, which was the first time we introduced people to TDD. So it changed the way how we build software. In the traditional development cycle, I'm a programmer, so I write code and I test it manually, then I spend time in the debugger, then I think it's okay, and I give it to the tester. Or even worse, I spend time programming and I just throw it over the wall to the tester and tell me what's wrong with it. This turned around. It turned around that now programmers will write what is the specification, the correctness of the system with a test, verify it works correctly, and then write a production code according to the specification. Okay. So it turned around the way we do development in a classic way. But what it did is actually people also talk about test-driven design, is that by writing tests, you learned more about your system. You learn about how to design better. And even people say that we learn how to, we learn a new way of designing, because sometimes when you look at your tests, if they're difficult, if the production code is difficult to test, it means something. It means there's something wrong with your design. So, Uncle Bob, which is a mnemonic for Robert C. Martin, a very famous guy that wrote several books about Agile and TDD. He wrote a famous classic one called Clean Code, came up with these 3 rules of TDD. And I guess Uncle Bob will read them like this. You shall not write a production code unless it is to make failing game test pass. What Uncle Bob means here is that my hands are tied. If I don't have a test to write, I probably have no production to write either. So nothing gets written unless there is a failing test to write to make up for it. The second rule of TDD is, if I am about to write a test, I should write the simple test I can write. Not over-engineer. Don't try to come up with 80% of your system just to test a little isolated part. I should be able to write the simple things that proves that something is not working, and then write something to make it prove that I fixed it. And that's the third rule, is that once I have the simple test, I should write nothing else but something that proves that now the test is actually passing. So people say that actually TDD has a rhythm or it has a beat, but also it has colors. The majority of our editors or IDEs will support that. It will show you red when you run your test to see that your test is failing, then green, then say, hey, the test is now working. And there's no color for refactor. I just think that blue is cool, so I just put blue for refactor. The refactor step is an optional step. It's a step where you clean up what you've done in the cycle of red and green, and but you don't introduce anything new. You don't write a new feature when you refactor. You just clean up the code so it looks better and more maintainable and more extensible. So programmers spend their day in this cycle, red green refactor, all day long, right? So let's look at closer at unit testing. We have a web of objects that speak to each other, and if we have to look at the object in the middle, and we want to unit test that object, we probably want to focus on this one and cut out the relationships or collaborations with the other objects. When we do that, it's called mocking or stubbing. I'm not going to go over that now, because you can do that without mocking frameworks But you want to cut out those relationships so it's easy for you to test in isolation. That's what unit testing really is. It's testing the object in isolation. So once I'm in there, this is when I apply my cycle. I go red with refactor all the time. One of the things that comes out is, how do I know I'm really done when I do the cycle in that object? Well, the first answer is, do you have any more tests to write? And if you don't have any more tests to write, you're done. But at the macro level, and we touched on that quickly on the other previous talk, is that this cycle also applies here in acceptance testing, where I'm building a feature and it involves normally more than one object. Then I do the cycle at that level and then focus on this object and come back up to the macro level to see when I'm really done. So what does it look in practice? Looks like acceptance testing is the way to kickstart TDD, in some cases, not always. This is an example, for example, acceptance testing that I write when I do Ruby. This is user registration, and it reads like this. Given that I'm on the sign-up page, when I fill in emails with whatever email, and I fill in password with secret, and I click on sign in, I see the welcome message. You can almost picture the screen that's behind it. It's a simple sign-up with 2 fields and a click button, and then there's a transition to a new page. That will be my acceptance testing. For unit testing, on top of my head, these are the unit tests that I think I could write later on. We normally want to make sure the email address and the @ ends up in .com or .tr or whatever. And the password is whatever is the password constraint that you normally have. 6 characters long, you need to have an uppercase, you need to have a letter, whatever fits you. So those are the 2 differences that I see on acceptance testing and unit testing. So this is all good, and it would be perfect if we could write the best code like this, but it doesn't, because code gets worse over time. And it normally happens where we start with a good design and good code, and over time it just goes down as we add more functionality and more features to it. And what happens is that code becomes rigid, fragile, difficult to change, and difficult to estimate. And that's pretty bad. Because the worst of all is for programmers, we have this fear of change, and we're stuck. And that's when we start naming classes or modules like Frankenstein. Because he's gonna go and kill his father, whoever created it is so ugly. Or Godzilla, he will go around and kill another village. This is not gonna be funny, you can laugh. But we don't want to be afraid of writing code like this. I mean, I work in project where we have Godzillas all the time. We want this cute cat. This is actually my coworker's cat. It's called Hassel. He's 1 month old at this point. So we want to have, play with the cat like this. This should be code, should be playful, it should be easy to write. So how can we get to that? Well, first we want high coverage. We want the highest coverage we can get. What's coverage? Coverage is a percent, or is a measurement. In this case, we normally refer to that as a percentage. But it's a measurement of tests that execute your production code. So if you have a lot of tests that execute a lot of your production code, that means you have a high coverage. Normally in TDD, you want to go for the highest coverage, 100%. Once you have that, it gives you a lot of confidence, because as I'm writing stuff and I'm running my tests, they will fail and they will tell me that I make mistakes. So I'll fix them. But I'm not afraid to go, because I know that I have a safety net that for me is that high coverage that makes sure that I catch every mistake before it gets to source control or even to the customer. We want the tests to be super fast. When I mean super fast, it's really, really fast. I want to be able to run thousands of tests under a couple of seconds. My whole system. And I want them to be super easy to run. Either click a button and they all run, or even better, give me a shortcut on my keyboard so I can press that shortcut and they run. Not even better, give me a way that every time I save my files, they all run, and I know exactly when I do mistakes. Once you get to that, the advantage is that you can release anytime you want, because you can cut software every day. If you fit the specification, if you have high coverage, if the test can run all the time, that means that tomorrow you want a version, perfect, take it, it's yours. For me, the biggest thing about this is, because I'm a programmer, I don't want to be on call. I want to enjoy my happy hours, I want to enjoy my weekends with my family. I don't want to be there to fix the mistakes I commit from Monday to Friday. Okay, so TDD, that's the thing. It's hard. It's a skill. It's not easy. When you start from scratch, it takes time to understand and learn it. So let's talk about that. How can we make it easier for us? Well, the first mistake that we do all the time is we mix business logic with instantiation of objects. And if we do that, we're going to have a really bad time trying to test drive our code. The code that you write should be either in the business of taking care of your logic or making objects that can take care of your logic, but not both. So on one side, to do logic, you have the strategy pattern and the single responsibility principle, that's SRP there. And if you want to build objects, use factories or the dependency injection principle on that side. Doing work in the constructor really sucks. We should stop doing that because it makes objects very difficult to build. And when you test drive, you want to make objects all the time. So here I have a new object, and I want to instantiate it, and everything goes very well. Until, oops, what's going on? This new object actually brought the file over to the hard drive, or maybe I don't have that file, and really, really sucks at that time. Or even worse, like, oops, it's talking to the database. So now what do? It's all stuck together. I cannot take that object and isolate it and test it. So we have to stop doing work with the constructor. Objects should be able to build themselves. Tell, don't ask. This is a principle as well from the XP practices. This is called train wreck. How many people have seen this code before? Something similar. When we get get, and we do something at the end. It's even wrong what we do at the end here. But we see this all the time. If you do this, it's a violation of the law of the leader, but also you have a problem here, and when you see this slide, you should be very uncomfortable. Code intimacy. Like, this code knows way too much about what else is going on in the system. Way too much. So don't have code to be intimate. That's a bad thing for programmers. That should gross you out. Tell and ask is about message passing, where objects talk to other objects with messages. They tell you to do stuff. They don't gather things about you and then decide what to do stuff. This is not the way we should code. We should go, so here I think it's going to do get the address, actually get the zip code and then calculate the shipping. But it's actually even on the wrong object. This is more like it. We should tell the order to calculate the shipping giving a zip code. Composition over inheritance. So we've been told this lie over that inheritance is actually the way we can reuse code. And this started maybe, I don't know, 10 or 15 years ago. Well, inheritance, you can reuse code and everything will be perfect because you probably have something like this. You have an animal class on top, and you have dogs and snakes and other animals and so forth. And, well, I can reuse code in a way that walking and making noise can be on the animal and everything is going to be dandy because I can reuse this code. It's a lie because if I want to add a cat, and say, okay, well, a cat is an animal. I'm going to put it right here. And it happens that a new feature for the cat is actually a cat can play. Oh, that's very cool, that's very cute. So I can just put the play method on the animal, and the dog will get it, and I know how the dog plays. But how the snake really plays anything? That seems like dangerous. You don't want a snake to play. You don't want to play with a snake. So that doesn't really reuse the code that you want to reuse. In the Java world, this is Java Web. It gets very hard when you want to test a Mars server here at the bottom because you have inherited all the other layers of servlet and HTTP server that do stuff. They probably, when you build them, they probably go to the database, or they go to the IO system, or they go to PayPal and put money on somebody else's account. It's terrible. Anyway, static methods are evil. And if you remember Godzilla, this is where Godzilla should be. Look at this method. So allowable value is loading a gender. Allowable value is a class that will return you what values you can have for gender in this case, where it becomes with male, female, unknown. Or if you ask him for phones, it will load you the phones you can have in the system. So residential phone, mobile phone, other type of phones. So it feels like something nice to have, some kind of nice utility, so you can have access to things. But this is what it does within the covers. It starts a process that posts an RSS feed, that sends you a message, that starts on the process, that uploads your resume to the cloud, calls somebody in India for support, analyzes your network, and takes money out of your account. That was supposed to be funny as well. And to tell you how evil it is, you don't know what's going to happen behind an innocent call like this. It can get very complicated and make your testing life miserable. And it's not as big. Do one thing. So that's what your code should be. Do one thing and do it well. Or when it has to change, you should have only one reason to change. How many times have you seen interfaces like this? Alright, so like I'm going down the list. Brew coffee and make toast. Looks like maybe a breakfast theme going on. That makes sense. Take photo. I'm not sure. Maybe I want to take a photo of the coffee and the toast. Blog has nothing to do with breakfast. Pet the dog. I'm not really sure. Wear blue jeans and write test. Nothing to do. The problem with having interfaces like this is that when you're trying to use it, then your code ends up with code in there that says, oh, it doesn't apply to this case, and it's terrible. So do one thing and do it well. This interface should be broken down into at least 7 or 8. So that's what the technical part, a bit of the talk. Now, we're going to talk about the cultural thing about how hard is really doing TDD. So let's make that really easier because, as I said before, TDD is a skill and it's hard to learn it, and when you are in a big organization, it's even harder. So learning is a bottleneck. TDD is something that you have to be willing to learn and take time to learn. So if I have to do it all over again, this is how I will do it. I'll divide my time. It doesn't have to be that accurate, but it's a good graph. I will practice. Practice is, have you guys heard about code katas? A kata in martial arts is when, for example, you go to karate and you start in the very little level and you do this all day until you know how to punch. And when you know how to punch, maybe you do a step here and then you punch again. Well, code katas is the same. You just do this punch over and over and over, but with tests. And you practice the same thing over and over. And it's very simple. But at the same time, when you master that, you go up to different levels. Another way of practicing is going to code retreats. Code retreat is a day where you practice all day test driving, which is great. It's a nice way to meet new people that test drive and develop your game. Pair programming. Pair programming, you should try to do it all the time because that's a nice way to level set also the knowledge around your team members and go faster in your projects because there's not one silo or area that nobody will know, and people will get up to date with the new techniques that the team introduces. Reading about, so staying up to with the trends and side projects where you just mess around. My computer is just full of side projects that would never see the light because I just think it's fun to just start something and never finish. Just for fun. So these are the steps I've seen over and over in organizations where we adopt TDD. At the beginning, we don't know there is TDD, so we're ignorant about it. And we don't know what the benefits are. Then all of a sudden, we learn about it and we say, oh, this could be great, let's try it. So we become test infected, where we don't really write the test before the code, but we write it almost at the same time. Sometimes a bit later, sometimes a bit before. And we really tried hard. And one day we noticed, oh, but writing the test first before the code is actually easier, so we become test-driven. But other people also actually get stuck in the test infected, where it takes some time. This step from here to here goes fast. From here to here, it takes some time, so you can drop down to here. Depends how you do it, because test infected you really want to give it a try, but if it's really, really hard, you say, no, TDD is not for me, I'm gonna go back to what I know, which is just throwing the test over the walls of the testers. So selecting the right project. We want to make sure that when we do TDD, or we adopt TDD, we don't do it on the most important feature for the next release. For example, this is a release for Angry Birds. This is a top secret slide, I won't show it to anybody. But they're going to be on Windows 8 and they got the Star Wars team. That's a must-have, Star Wars. And what you have is going to be new features here that maybe don't make sense or not, but this is where you want to start TDD, for stuff that is not that important. Because it's going to take time, and maybe you're going to have to skip deadlines. So I've seen this as well in big organizations where we normally comes from the top, and the organization says, hey guys, it's all TDD now, everything is cool and dandy. And this is what normally happens. It's chaos. Because we all spin our wheels, the analysts don't know what to do, what does it mean for me TDD, should I write acceptance testing, or should I not, and there's this big chaotic thing going on. I should have maybe inserted Godzilla back into this one. So a way that I've seen that we were able to succeed is to pick a team, but pick a team that has two things. That doesn't have the priority number one, that doesn't have to deliver stuff that's really, really important, but still need to deliver something. And pick a team that people are willing to try. Don't try to assign people to it and say, you're going to start doing TDD, because that's not going to work. But learn about who wants to give it a try, an honest try, and put them on the team together. That may work. When that happens, and you see success, then you mix in the teams. And slowly the whole organization actually will be test-driven. So give them support. Give them support is about opening your doors to this practice. And say, okay, so I will buy you breakfast every Friday when there is a TDD talk. Or I will give you a room so user groups can come in and talk about TDD as well. I will put time aside so you can learn and bring you a trainer so you can get better. And I can buy you a new license for your IDE, or I can, all that kind of stuff you can do for it to succeed. So this is a summary of it all. High coverage, super fast test, easy to run, can reason in time. I want less bug, I don't want to be on call. Technically, I want one responsibility, I hate static calls. Don't make me do anything in the constructor. Pass a message. Favor collaborations over inheritance. Learn together, pick the right project, start with a very small group, and give them support. And